Alright, let me tilt this where you can experience all of the glory of the popping reefer capacitors. Let's see what happens. Well, no flames yet. It is possible that it won't run without a load. Let us find a load. I know I had somewhere here a broken disk drive. Here is a load. We could also just use some resistors or something if we wanted to. Let us see if something explodes. The fan is running now that there is a load on the power supply. Let me see. That was that funny board that went to the -5 volts. -10.3 volts, good enough. 8.3 volts, rather weak. 5 volts. I shall clean it up and put it back in the machine. While I am in it, I am going to go ahead and clean this contrast pot with some deoxit applied with a needle oiler. Hopefully that will keep everything very happy, because we like when our computers are happy. I have finished cleaning the power supply, but before putting it back together I have attached it to the load again so that I might check for ripple. I have my scope set to 500 millivolts per division, which is fairly low, and we will see if there's any noise. Now, if we had ripple on here, we would see a sine wave. That's just noise. I turned it down to 100 millivolts. That is good and clean. That is good and clean. I have it set to AC coupling so that we're only seeing the changes in voltage. Even though I'm looking at the 5-volt lines, it still displays it in the center of the scope, of course. Now that is either the 5 or the 12 or the negative 12-volt line. I'm not sure which. And it has a tiny bit of ripple on it, but not enough, in my opinion, to worry about. It's probably a capacitor that's past its prime, but whatever. It's only that one line. Which line is that? That is the white wire. Let's see which the white wire is. The white wire is the negative 12 volt line, or negative 8 volts in this case. That does seem a tad low. But if it's only being used for RS-232, it's probably close enough. Alright, I'm satisfied for the moment. Although 10 volts and negative 8.5 or whatever it was volts are both a little low, but the 5 volt supply is fine. So let's just put it back together and see what happens. Alright gentlemen, the power supply has been reinstalled, the CRT analog has been reinstalled, the neck board has been plugged back in. No power other than the fan has been plugged back into anything yet. We've got AC line plugged into the power supply. Flip the switch here, see what happens. Probably nothing will happen since there's no load, but just making sure. Alright, now let's see here. This one here is the one that plugged into this board. Let's see what happens now. It would certainly sound like the main board is running. Let us plug power back into these two boards here and see what happens. Okay, so far so good. Let's turn the machine around, apply power to the CRT analog board, and see what happens. I should have done that before I had only one hand free. Oh, that's fine. I have plenty of experience working at computers with only one hand free. Anyway, let's see what happens now. Hopefully there will not be any explosion. That would make me very sad if there is. Okay, here goes nothing. I flinched. Ooh, I smell it. Vertical collapse. We have a driver transistor dead on the CRT analog board, would be my supposition. This will require more head scratching. The CRT appears to be fine though. That is a great relief. And all the high voltage shit seems to be working. So, very good. Very, very good. Alright, let's see what happens on an external monitor. That looks promising. Okay, so it is an analog board. Personally, I think it's one of these transistors. Some vertical deflection transistors screwed up, and I know even less about this than I know about anything else, so I may be full of shit, and I don't know how to figure out which transistors it would be. It's all discrete. This isn't one of those boards that uses like a chip that does all the horizontal and vertical deflection stuff magically. It's doing it all with these transistors somehow, and I need to figure out which one's bad, or I could just start replacing transistors starting starting with the one nearest to the vertical size control, because you'd think that might have something to do with the vertical deflection. I don't know. If you got any ideas, let me know. From what I've read in the past, vertical collapse like that isn't usually caused by bad capacitors. It's usually some driver, transistor, or integrated circuit that's fucked up. And none of these capacitors look skeezy or anything, so I don't know. What do you guys think? You know how I'm always shitting on people for just replacing capacitors willy-nilly without actually figuring out what the problem is first? Yeah. I don't expect this to actually fix the problem. I am still pretty certain that there is a blown transistor here somewhere, a blown driver transistor on this vertical deflection yoke. I did check the yokes, or the coils on the yoke, both the horizontal and the vertical one, on an ohm meter, and this one's like 28 ohms and this one's like 0.3 ohms, which people tell me is within spec. So there's no open coil on the yoke here. Let's try it. Fuck it. See what happens. Did I get the dagger? Yeah, I did. Okay. Here we go. Alright, we've still got vertical collapse, but I think we did fix something, because if you recall before, the line went all the way across the screen, and was like rippling and shit, and now it's stable right there, in the same position that the text was when we had the external monitor plugged in. So I guess replacing those capacitors did fix something. I want to try to draw a schematic of part of this horizontal section. Let me see if I can grab it here and show it to you. I took a photo of the foil side of the board and changed it into black and white tracing and flipped it and overlaid it on top of the component side of the board here. So hopefully this will help me draw a schematic of the horizontal section, or vertical section here, and figure out which of these transistors are doing what. I don't know if I'll have time to continue this anymore this evening, but I'll be back with you sometime. Thanks for joining me. If any of you have any ideas as to what's going on here, please let me know. The transistors on this analog board, most of them are ITT brand transistors, and they've been out of business for a long time. I found a 1974 semiconductor product catalog that lists all the specifications of the transistors that they offered in 1974, but the ones that are on this board are not in that book. So if any of you guys have an ITT data book from like the 80s, please let me know. I think one of the ones we're looking for is the ITT 1040, and then this other one here is a 1036 TZ, with, I guess TZ's probably the manufacturer marking, 1036 is the part number, but I haven't found anything on that one either. So if you got any clue sticks you can hit me with, please do. Alright, thank you for joining me. Have a lovely evening, gentlemen.